All right. If you haven't done so already, please make sure that you put your first and last name on your packet. Today is the 21st, 2, 21, 22. We have our warm up that's due this week, our homework. We have a test on in Tuesday, that's tomorrow. We're gonna skip tutoring this week. Well, if you need it, I'll be here. Wednesday, 3 p.m. It's virtual. Somebody still might need some help with something. And then we're gonna start our next unit on Wednesday. Okay. We're gonna do our warm up today, which you should have already completed. So I'm gonna go over it. Then I'm gonna finish going over the study guide. If you have any questions, just let me know. And then you're gonna finish your group assignment. And that was online. That was the word problems. Your homework is in the packet. Okay. All right. Let's write in our planner. This is the week of February the 21st. Through February the 25th. This is Q3W5, Math 1. You have homework. We have virtual tutoring on Wednesday. 3 p.m. We have Math 1 homework here, but we also have a test here, okay? Please make sure you study. Okay? And that's what's coming up so far. And math work is due here. All right, so let's look at the warm-up. All right, Brenda invests, this is an investment, $4,848 into a savings account with a fixed annual interest rate of 5%, compounded, bless you, 2 times per year, okay? What will the account balance be after 6 years? This is exponential growth, but which formula are you going to use for this particular problem? Compound interest, okay? You're going to use compound interest formula. Okay? And what's the compound interest formula? We got A or Y is equal to what? Anybody? P parentheses, 1 plus R over N to the NT power. Okay, very good. All right, so what's going to be our P in this problem? 4,848. This is our starting amount. Okay, this is our starting amount times 1 plus, what's our R going to be in this problem?
0.05.
Very good. Divided by what?
2.
2. That's how many times interest is being charged twice a year. To the what power?
6 times 2.
6 times 2. What's 6 times 2?
12.
12. So now we're going to figure out what that amount is for 6 years. So I'm going to clear my calculator. Second plus 712. And I'm going to type this in. $4,848 times 1 plus 0.05 divided by 2, caret key 12. Okay, that's what I type in. And how much money does that give me?
6,520 and
How much money? $6,520 and how much cent? 2 cents. That's after 6 years. Did anybody get that right on their own? Okay, that's good. All right, so now let's look at the next problem. This is what you should have gathered from the already. You're graphing the two equations to see where they cross each other. That's how you solve it. Solving a system means to find what points they share. So their point of intersection is the solution. If they don't cross, then they have no solution. All right? So let's look at this one. Let's graph this equation first. First thing you do is label your M and your B. Your M here is -5 over 3. Your B is +3. So you label your M and your B first. Now you're going to find your B on the y-axis. That's your y-intercept, your starting amount. So B here is up 1, 2, 3. And now I'm going to go down 5 and to the right 3. So let's go down 5. 1, 2, 3, 4, 5. 1, 2, 3. And we don't have enough space to do any more points on this line. So I'm going to draw my line, extend my line, make sure I put arrows at the end. Now I'm going to graph the second one. Again, I label my M and my B. My slope for this linear equation is 1 over 3. This top number is your rise, the bottom number is your run. And then my B here is -3. Okay, so I label my M and my B. So now I'm going to find the B, the starting amount on the y-axis. -3 is right here. Oops, sorry, y'all. That is not -3, that's -2. And now I'm going to rise. I'm going to go up 1 and to the right 3. So I'll go up 1 and to the right 1, 2, 3. This is the point they cross. Up 1, and I don't have enough space to go this way. But if I want points in the opposite direction, instead of going up 1, I go down 1. Instead of going to the right 3, go to the what? And this is my second line. So my solution is going to be this point right here where they cross each other. That ordered pair is going to be positive 1, 2, 3, and -2. This is the solution. That's the one point they share. Any questions about that? Anybody still copying? All right. This is your homework for tonight. Do not forget, please put this on a separate sheet of paper and show all of your steps, okay? Any questions? Go ahead and put that away. Take out your packet from last week so that we can continue um, making sure we understand the problems from the study guide. I only had a couple left. Yes. From last week? Okay. I think that's where we left off at. Let me pause. Okay, this is the last one I think we left off on, so let's do 19. 18? Okay, yeah. All right, so with 18, please listen. This is telling you that your first number, how do I know it's first number? Because say a sub 1. So my first number is 4. Now, because I'm starting with my first number and not the 0 number, that's the only reason why it's saying a sub n minus 1, because I didn't start with the a sub 0. I started with the a sub 1. So that's all this is saying right here. Bless you. Okay? So what do they want you to do? They got 1/2 before this a sub n minus 1. So they're saying multiply a half to get the next number. That's all this is telling you to do. So you're going to multiply each number by half to get the next number. So the first number they start off with is 4. Then they multiply 4 times a half. What's 4 times a half?
2.
That's how they get 2. And they want you to find the 7th number, a sub 7. So then the next number, when I multiply 2 times a half, I get 1. When I multiply 1 times a half, I get a half. When I multiply 1/2 times a half, that gives me 1/4. When I multiply 1/2 times this 1/4, that gives me 1/8. When I multiply this 1/8 times 1/2, that gives me what? 1/16. Okay? So this is the 7th number. 1/16. That's how I get A. Okay? Any questions about that? All right. Number 19. The frequencies for certain notes are shown below. These are the frequencies here. It's saying that it's a geometric sequence. That means they're multiplying to get to the next number. So you have to figure out what's the common ratio, what number is being multiplied. So work backwards and divide to figure out what was being multiplied. So you're going to say 466.16 divided by, and I said 12, Lord, forgive me, divided by 440, okay? To see what number was multiplied, we're dividing. Okay, so we're working backwards. Let's type that in. 466.16 divided by 440. And what does that give you? Say again, baby. Okay, 1.06. Very good. So my answer here is going to be C. Yes. Did you have a question? Okay. All right. Terrence's spending account balance, it represents this formula right here, okay, where the time is elapsed in weeks. What is the account balance after 2 weeks? So what, in order to find the answer here, we have to substitute 2 in for what letter? I'm sorry. T, for T. Okay. Any questions about that? What did you get as your answer for 20? C. Okay, C. All you're doing is substituting. You get 100 times 0.9 to the second power. And that gives you C. Okay? Yes. '21. At the end of 2006, the population for Riverside was 400 people. The population for the small town is modeled by the equation below, where T represents the number of years since 2006. So 400 is the starting population, okay? Represents the number of people. So this is the equation. Based on the model, approximately what was the increase in the population from 2009 compared to 2006? So we got to figure out the population for 2009 and figure out the population, and see what the increase was. So how many years is it after 2006? Three. So you got 400, 1.2. Let's do to the third power. Let's see what that is. 400 times 1.3 caret key 3. And that's going to be 691.2. Okay, so what was the increase? How do we figure out how much it increased from this year to this year? What do we do with this amount? This is the amount for 2009. How much? Say again? Subtract. So what are we going to subtract? Very good. So let's subtract and see what we get. Minus the 400. And you can do this. You can just kind of look at it and tell. How much is this going to give you? Okay. Number 22. A scientist conducted an experiment to observe a half-life. Half-life means if the dosage is 50, how long does it take for it to get to half of that amount, which would be 25? Okay. So let's look at this. The scientists conduct an experiment to observe half-life period of radioactive element barium. He starts with the experiment. Start with 200 grams of barium and record the mass for every 13 days. All right, so we got to write an equation for this. The easiest way to write an equation for this, because it's skipping days, is to type it in the calculator. Where do I go in the calculator to type in an exponential function, or to not type it in, but to find the equation for exponential function? No, I have to have the equation. I don't have the equation yet. I go to stat, then where? Edit. And so now I'm going to type this in. Please do this with me so you'll know, because you definitely will have to do this on your test. So we got 0, 13, 26, 39 over. Then we have 200, 100, 50, and 25. Make sure you type the numbers in correctly. Oops, excuse me. Type this in, Sammy. Come on, type this in, y'all. Where's your calculator? Okay, can you ask somebody else nicely to go get it for you? Hatcher, can you please go get his calculator? See, that was easy. He's a nice fellow. All right. So where do I go after I type this in? Where do I go next? Stat. Then where? Calc. Then where? Expo Rig. And now what do I type in here? Second L1 or second. Y bars function. Okay, now we press enter. Now look, we have just put this equation under y equals so we can look at a function table. So let's look at the function table. These are the days that they give you. I can just type those days in. Second, the window, and go to X. Instead of just, I just type my own X values in. X is the number of days. So now I can type in 13 to see if 13 will give us 1.5. And it doesn't. It's 100. 65, that doesn't give me 1.5 grams. 91, bless you, that gives me close to 1.5 right there. And then 104, oops, that's 10. 104 doesn't give me 105. So 91 days is my answer there. And did you get all of this stuff down?
Yes.
Okay, you playing too much. Do I need to move you back up here again? Okay, come on now. Yes.
Can you go back a little bit?
For the whole thing? Did you stat? Huh? I mean, all of it was in. Okay. Did you type the numbers in?
Yeah.
Yes.
Yeah.
Okay. Then you went to stat. You went over to calc, and you went down to expo reg.
Yeah.
Yes. Okay, and then you press second 1, comma, second 2,
Yes.
comma, vars, y vars, function. You did all of that, and then you press enter. Okay, and so okay, and then I just looked at I went here, and I went second graph to view the function table. And then if you want to type in your X values, you press second window, and you see right here where it says auto,
Yes.
switch it from auto to X and press enter on X. And that will allow you to type in your X values. Yes, ma'am. You just have to wait for the pass to come back. Anybody else? Do you understand?
Yes.
Okay. All right, let's move on to the next one. It says, what is the y-intercept of this function? Anytime you're trying to find the y-intercept, that's where your x value is equal to 0. Okay? So you're going to substitute 0 in the place of x. So this is going to be y is equal to, y is the same as f of x, okay? 3 over 2 to the 0 power minus 7. What's anything raised to the 0 power? 1. So this is going to be 1 for this minus 7. What's 1 minus 7?
-6.
That's -6. Any questions about that? Sammy, sit up. Okay, number 24. The population growth for a species of birds in thousands can be represented by this function right here, where T is the number of years since 2002. So the starting amount is in 2002. What is the approximate average rate of change in the population between 2004 and 2007? So I got to find 2004 and 2007 and then do the slope formula to find the rate of change. So let's figure out what it is for 2002 and 2007. All right, so I'm going to type second plus 712. And I'm going to type this in. 20 times 1.24 caret key x. I'm going to put it back on auto, and I'm going to view my function table. Oops. Oh, I didn't type the equation in. Sorry, y'all. All right. So now I'm going to view the function table. If 2002 is the starting year, which one of these is going to be 2004?
3. 2.
2. Right here. So this is going to be 30. This one's going to be 2. This order pair is 2, comma, 30.752. And then what's 2007? 5. So this is going to be 5, comma, 58.633. Okay, so now I have both of those ordered pairs. So now we got to find the average rate of change. So you use the slope formula, y2 minus y1 over x2 minus x1. So now you're going to label these points. This is x1, y1, x2, y2. What are we going to put on the top? 58. And they're only doing one space behind the decimal, so let's round this to one space behind the decimal. So let's make this 8. And let's make this 6. All right. So you're right. It's 58.6 minus 30.8. And then what do you put on the bottom?
5 minus 10.
5 minus 10. Okay, so let's do the top. That's 58.6 minus 30.8. And what does that give you?
27.8.
Very good. 27.8. Good job, y'all. And then on the bottom, what does that give you? 3. So let's divide and see what we get. Divide this by 3. And that gives us about 9 point what? 9. We're rounding to the nearest tenth place right here. So it's 9 point. And that answer choice is what? 8. Okay. Any questions about this? Sammy, make sure you write this stuff down. All right, the last one. Was anybody still copying that? All right, so let's do this one. The population of the 2 culture bacteria. This is a bacteria A and this is bacteria B. Okay. So which statement is a correct comparison? It says the initial value for population B. This is population B. This is 75. Yes.
I don't want to be that guy, but can you move the mirror in, please? It's starting to get really annoying.
Okay.
Thank you.
Yeah, he knows it. He's packing up. Bless his heart. Come sit up here, please, sir. All right. This is 75. That is a shame. That is a shame. That is a shame. I don't have no words right now. All right, this is 100. This is 75. So this is saying that the initial bacteria B, okay, which is 75, is more than initial for A. It is not. This is 75. This is 100. So this is not true. The population for B and the population for A and the population B will never equal the same. At some point they would. You just have to find it because they don't grow by the same amount. So at some point they are going to cross paths at one point or another. So this is not true. Okay? Because their populations are at different amounts. They're increasing by different amounts. So at some point they would cross each other. The population of bacteria B is greater than the population of bacteria A in 3 hours. So we got to test this one, okay, to see. But let's look at the last one to see if this one's easier to find. The rate of growth, no, because you still have to have the equation. So we're going to do the equation for both of these. Let's do the equation for A first. So we're going to type these points in. That's stat. That's edit. So we're going to type these 3 points in. We got 0, 1, 2. And then on this one, we got 100, 120, and 144. Okay? So those are our 3 points. So now we are going to go to stat, calc, and go down to which one? Expo Red. L1, comma, L2. Elijah, you got that? Did you get it?
I'm getting it. Yeah.
Okay. I'm going to slow down a little bit. And this comma, vars. Then we go over to Y bars, and we're going to put this under Y1 in our calculator, okay? So this is the equation for the first one. So my my growth rate is, or my growth factor, sorry, is 1.2, which is basically 20%. All right. Okay, so let's do this one. We need some ordered pairs. And put the ordered pairs out to the side. We got 0 and 75. What's another one? We got this point right here, 1 and 100. And let's try to see if we can find another one. Maybe 3 and 160. Okay. So let's type these in. Please watch what Miss Reyes does because, look, this equation is under Y1. The next equation that we put, because we're comparing the two, we're going to put it under Y2 this time. So go to Stat, Edit. I don't want to delete this, so I'm going to use L3 and L4 to type these in. So this is going to be my X, 0, 1, and 3. And this is going to be my Y. L4 is going to be my Y. 75, 100, and 160. Okay. If I lost you at this point, please tell me so I can back it up a little bit. Is everybody okay with this being X and this being Y? Okay. Did you type this in?
No.
Come on. You're just sitting there chilling. Yes, baby. 160. Oh, it's 2.5. Thank you. Woo! So glad you caught that. Our equations get ready to be off. All right. So go back over here and put 2.5. Thank you. All right. So now I'm gonna find the equation for this. So we're gonna go to Stat, Calc, Expo Rig. And this one is going to be second. Instead of second 1, it's going to be second, what do you think? Second 3, comma, second what? Second 4. Okay, comma, what? Vars, Y bars, function. And this time, not this one, we're going to put it in this one. Okay, so now we got both equations in there. Do you see it? Okay, so now let's make a comparison. We're going to go to the table, second graph, and we're going to look for where is it 3 hours? Okay, so 3 hours, this one is at 172, and this one's at 185. The population of B is greater. Do you see how B is greater than A? So C is our answer here. And then it said the growth rate. If I wanted to look at the growth rate, for this one, 1.3, I would use B minus 1.3, and this is 1.2. So yeah, no, this one's B is not less than the other one. Actually, A is less percent than B is. Okay. Let's look at 26. The number of kilograms or radioactivity element that will remain in T hours, tongue-tied, is this equation right here. What is the rate of decrease? What formula do we use for the rate of decrease? Yeah, I mean, it's exponential decay, we know, because this. But how do I find the rate of decrease? See, all of these are percents. How do I find the rate of decrease? Excuse me. I had this off. It's B is equal to 1 minus the R. I'm going to substitute B and put it here, which is 0.91. How do I get R by itself? Subtract 1 on both sides. What is 90.91 minus 1? Negative 0.09. And then over here, this is going to be what?
Negative R.
All right. Now what do we do to get R by itself? Okay, and so then this becomes 0.09 is equal to R. How do I write this as a percent? And so what percent of decrease is this going to be? 9% decrease. So that's A. Any questions about how I found this? Okay. Number 27, the value of painting was 1,900 in the year 1990, excuse me. Since then, the value of the painting increased by 15% each decade. Which type of function best models this painting over a period of time? Okay, is this exponential? Is this situation exponential or linear? It's exponential because it's growing by 8%. So it's exponential. So mark out the linear ones. Okay, is it exponential because the value is increasing by a constant rate per decade? No, increasing by a constant rate per decade, that's more linear than explaining exponential. Um, the value increasing by a constant percent per decade, that's what it's doing. Okay, this is exponential growth because it increases by a percent, not a constant rate. That's more linear. The last one, Mrs. Turner, has two different accounts that can be modeled. This is the first one, this is the second one. Which best describes the two accounts? Okay, so this one right here is exponential. Is it growth or decay? This first one is growth. Okay, what about the second one? This one is decay. Okay, so account one is an example of exponential growth, while account two is an example of exponential decay. Is that true? Yes, that's true. Account one is example of exponential decay. That's false, okay? Both account one and two are examples of exponential growth. No. Both account one and two are examples of exponential decay. So the best answer is A. Any questions? All right. So now what I need for you to do is to finish working with your group on the word problems that I assigned. And if you have questions, please ask. All right.